we've been looking at sequences. So we have a sequence a sub n equals 1 plus 1 over n all to the n, and we want to find what it converges to. We know by theorem 1 in section 10.2 that if we take the limit of a sequence and it converges to something, then that's also what the sequence converges to. So we're going to start with taking a limit. So we have the limit of 1 plus 1 over n to the n, and we're going to call this limit L. Now if we just take the limit like this, it's going to be indeterminate because we're going to be raising something to the infinity power. So what we need to do is we need to manipulate this side so that we can get it to a limit that we can actually take. So we're going to start by taking the natural log of both sides, and this is why we make it equal to L, so that we can do the one thing to both sides. So, and this is the limit as n goes to infinity. So we get that. We still can't really do anything, but now we can use properties of logs. So we can bring this n down. We can have the limit Now we're going to just sort of write things that are equivalent, but just in different ways so that we can change it around. So we're going to take this n and we're going to put it on the bottom of a fraction. So we're going to have the natural log of 1 plus 1 over n over 1 over n. So we still can't really do anything, so we're going to use L'Hopital's rule, which means we take the derivative of the top and the derivative of the bottom. Okay. So the derivative of this is 1 over 1 plus 1 over n times the derivative, times the derivative of the inside. It's a chain rule. So the derivative of 1 over n is negative 1 over n squared. And on the bottom, we also have negative 1 over n squared. This is still equal to the natural log of L. So now we're just going to put this back on top. So we'll have the limit, and we have negative 1 over n squared over 1 plus 1 over n. And dividing by a fraction, you can flip and multiply. So this is going to be negative n squared over 1. And these are going to cancel. So now we just have the limit as n goes to infinity of 1 over 1 plus 1 over n. And that's the natural log of L. So we can take this limit. So if n goes to infinity, this term right here goes to 0, and then we just have 1 over 1. So now we have that this is 1, and that's equal to the natural log of L. So now we just have to get back L, because L is our limit. So we're going to take both sides to the e to both sides, and we're going to get that L is equal to e. So the limit as n approaches infinity of 1 plus 1 over n to the n is equal